Hello everyone, my name is Ram and beside me is Zahir. We both have embarked on a project using Mario to actually create an exercise circuit. So our exercise circuit is done in such a way that to assist users or participants to actually monitor them and how they're doing the exercise and whether they're doing it properly. So our exercises basically focuses on our core muscles. Hence, the two of us actually decided to create three main form of exercises. So I focused on two main exercises, and Zahir actually did the last exercise. The two exercises that I focused on are planking, and the second exercise is a sit-up. Then Zahir actually focused on leg raises. So I'll just basically explain what are the what are the first two exercises. So planking is where you actually lie flat on the ground and behave like a plank, where your your whole body is just a few cm away from the above from the ground, and you're maintaining it in a very horizontal position parallel to the ground. Sit up, as we all know, is just bending of your legs and lying flat and coming up and going down. So that's how sit up works. Then I'll let Zahir explain about his exercise and how how it will be useful in the circuit.
Okay, so basically my exercise is just the leg raise. Okay, leg raise it also trains your abs. Okay, but the main thing is how to do it efficiently is you have to position your leg at a certain height. So if you don't position your leg at a certain height, it's just not an effective exercise. So the aim of this whole so-called experiment, you can say, is to allow users to do a proper leg raise. And in this case, your leg is positioned between 25 to 35 cm. So what our Mario will do is that it will help you know that you are doing, you are positioning your leg at the right height. And in this case, it's not only for my part, even for Ram's part, this Mario is going to help everybody do their exercises properly. And how it makes sure that you do your exercise properly is using a counter also. So by using a counter, it will make sure that you do your exercises effectively. So I'm going to pass to Ram.
So with that, we actually would like to show you how we designed our whole exercise circuit in terms of lab view, as well as we also provided demonstration for you all to see how the whole thing was done. So without further ado, we will move on to the exercises. Thank you. Okay, for this project, right, we are basically using the sonic rangefinder to create a planking planking exercise. So how this project works, how this design goes by is, firstly, you can see here where my mouse is. We created a serial port which is connected to a UART selector, followed by where the serial port requires a baud rate of 9600 and data bits of 8. This serial port then passes the information to this icon, where it reads whatever is inside the serial port, which is then being passed on to scan from string. Let's say your sonic rangefinder is 12 inches away from an object. So the information that is passed down to this scan from string will be R032. So what this one does is it eliminates the R, and what this percentage U does is it makes it as an unsigned number. So eventually you will get 13 inches away from an object, which is then being passed down to this group of icons, where this group of icons will actually portray the inches being in between 10 inches to 15 inches. So let's say if it is 13 inches, then the boolean will light up. If it's not between that range, then the boolean won't light up. Moving on to our counter. So what happens is, based on this boolean, a property node is created. So what happens is, every single time the boolean lights up, this counter starts running. So this counter will run for 10 counts, and these 10 counts is every second. So what happens is, let's say if this thing lights up, this this value which is on will be passed on to this boolean. So this boolean will then activate this counter. When it's true, it will just add the whole counter by 1, and which will be reflected in the meter. And after you finish 10 counts of your planking, the second boolean will light up, indicating that you have completed your whole exercise. So basically, this is how our layout looks like. And moving on to how the whole Mario was set up is, uh, we just basically use the guide, the project guide, and connected the whole device, where your power pin, which is at 33, provides 3.3 volts to the sonic rangefinder. Then it's also being grounded at power pin, it's also being grounded at pin 30. And lastly, it's the UART pin, which you take the reading from, is at pin 10. So whatever reading is being passed from the rangefinder is passed into UART pin 10, which is then being passed, like what I said, which is then being passed to the serial port. So this is how the basic planking exercise system works, and now you can actually watch how the demonstration is being done. Thank you. Okay, this is the basic layout for the setup counter using accelerometer. So how this thing works is, firstly, it draws the values from the MyRio inbuilt accelerometer, which is inside. So this icon, what it does is it draws the value of different axes, and after that, in this case, we're actually using the y-axis to draw the value of the y-axis itself, and after that, it's being passed on to a differentiator. So after it differentiates, the value is then being compared with the threshold. So if it's true, the boolean will light up. So this is the basic setup test. So let me explain in detail. Firstly, let's look at the y-axis itself. So what happens is, why we took the y-axis is because initially your z-axis will be having a g-force which is of 9.81. So when you actually do a sit-up and when you sit upright, your g-force is now being transferred to the y-axis. And how this happens is, what basically happens is your z-axis become the y-axis and the y-axis become the z-axis. So we're just playing around with the g-force. And what this differentiator does is, when you're actually making the change from the y-axis to the z-axis, from the z-axis to the y-axis, the g-force will be changing, and you can see that the axis will have a sudden change. So this differentiator will pick up the sudden change and will compare it with the threshold. And how we found the threshold is because by doing numerous sit-ups and actually deriving this threshold. So if you were to go above the threshold, then the boolean will light up. And how is this interlinked to our counter? So this property node, as you can see, is the one linked to the boolean. So whenever the property node detects a true, or when the boolean lights up, it will trigger this icon. So when it is true, the counter will be increased by 1. When it's not true, it will retain its previous value. So the whole sit-up exercise is actually basically a 5 sit-ups. So if you were to hit 5 sit-ups, then the second boolean will light up, indicating that you have completed the whole exercise. And that's the basic layout for the sit-up counter itself. Now we can actually sit down and watch the demo of the sit-up counter. Thank you.
Okay, hi guys. Now I'm going to explain the next exercise, which is leg raise. So in this case, we are using a IR sensor. Okay, so this IR sensor is an analog device that where the inputs are being fed to the MyRio, okay, via pin number 3. Okay, so once the input is fed into MyRio, it will then convert to a DC signal using the analog to digital converter. Alright, and then the output will be converted by using a formula converted to a CM value. Now, by using the CM value, it will be used to compare whether your lead is between 25 to 35 cm. So this whole part of the circuit behaves like a comparator. Okay, so as long as your leg is between 25 to 35 cm, this information will be fed to the Boolean switch, and the Boolean switch will remain green as long as your leg is between 25 to 35 cm. As long as your feet is between 25 to 35 cm. But if it's out of this range, your green light just switches off. Okay, so next, this brings me to the counter. Okay, so in this case, the counter behaves the same way as what we showed during for the ultrasonic sensor for our planking exercise. So as long as your boolean is true, okay, you can see that there's this boolean here. As long as your boolean is true, your counter will increase by 1, or else it will just stop at the previous value. So this counter is important to make sure that your leg is between 25 to 35 cm. Okay, so it ensures that you do a standard leg raise. So without further ado, we will just and before I start the demo, please take note that the counter will increase up to 10. After that, it will just your LED will, there's this boolean where the light will turn red. Okay, you will see that in the demo. So let's start the demo. So in conclusion, I believe you have seen from our demos that how MyRio can help people train their apps effectively and efficiently by using your boolean, your lights, and also your counter. So yeah, basically that's it.
So with that, we would like to thank Mr. Professor Kanwan Singh for actually allowing us to explore our our capabilities by using MyRio and also creating a exercise circuit which might be useful in the future, be it home or be it in army or any other exercise vicinities. So I hope you all enjoyed and learned from what we did. So we would like to thank you all for watching. Thank you.
Thank you. Hello guys. So we have done all the exercises, but it's not over yet. So what I want to show is how an IR sensor detects motion. Okay, this can be used for security purposes. It can even be used for people at home if they enter their house and you want the light to be on automatically. So from here you can see from the LabVIEW program, okay, the same thing. IR sensor takes in the analog input, and from the analog input it converts from using analog to digital converter, it converts to DC signal. DC signal goes through a comparator. Okay, in this case, as long as an object or person is between 10 cm to 150 cm, your LED lights up. Okay, so this is how the whole mechanism is working, and in this case there's no counter. So let me show you a whole demonstration. Okay, when I cross the IR sensor, you will see the LED lighting up. So in this case now the LED is off. So now I'm going to cross. Sorry. Okay, Okay, you see the LED lighting up. Okay, thus we have come to the end of all our demonstrations. Thank you.